In this video, I'm going to explain what DNS is and its purpose on the internet. Computers speak numbers, we speak words. Imagine if you had to memorize a complex string of numbers for every single website you wanted to visit. That's actually how computers communicate. Say you type youtube.com, which is easy to remember, but your computer needs something entirely different, almost impossible to remember. There's a massive language gap between humans and machines. We need a translator to bridge this divide. To understand DNS, domain name system, just think of the contact list in a smartphone or an old school phone book. In the old way, you'd look up a name to find a number. But the DNS way, your browser looks up a domain to find an IP address. DNS exists solely to make the internet human-friendly. Without it, we'd be navigating the web using calculators. This is how DNS translation works. The process happens in milliseconds, but there is a specific conversation happening behind the scenes every time you hit enter. You enter a domain name like wikipedia.org into your browser bar. Your computer shouts out to the network where it is. The DNS system checks its records and responds with a specific IP address and connection. Your browser uses that address to load the website instantly. This is the DNS team. Finding a website isn't a one-person job. It takes a team of 4 specialized servers working together. The first one being recursive resolver. This is your first stop. It's the server that goes out and does the hard work of finding the answer for you. This is the root server. He doesn't know the specific answer, but it knows exactly he does. He points the librarian in the right direction. The TLD server, also known as top-level domain server, manages specific endings like .com, .org, or .net. They narrow down the search. And finally, authoritative server. The final stop. This server holds the actual IP address record you're looking for. This is an example of finding youtube.com. Your computer asks the recursive resolver where is youtube.com. The librarian asks the root server. The root server says I don't know, but go ask the .com TLD server. The librarian asks the .com TLD server. The TLD server says go ask YouTube's authoritative server. And then the answer is found here. The librarian runs back and gives the IP to your computer. YouTube loads. Just like a contact card might have a home number, work number, and email address, DNS has different records for different information. A simple record, the standard IPv4 address, this is the main phone number for your website. Quadruple A record, the IPv6, a newer, longer format for the modern internet. CNAME, which is like a nickname or alias, it maps one name to another, like goo.gl to google.co. Mail exchange, it tells the internet where to deliver emails for that domain. Text records, used for verification notes and proving you own a domain. So you might ask, wait, does my computer do that 4-step journey every single time I visit YouTube? Nope, that would be way too slow. Enter caching. Once your computer or resolver finds an answer, it remembers it for a while. It's like putting your best friend's number on speed dial, so you don't have to look it up in the book every time you call. Cached lookups happen almost instantly because the data is stored locally on a machine or nearby ISP. Now, why does cybersecurity care? Because DNS is the backbone of the internet. It's a major target for attackers. If you control the phone book, you control the calls. DNS poisoning. Injecting fake entries into the phone book. Users type bank.com but gets into a fake website. And then there's DDoS attacks, overwhelming the DNS system with traffic so legitimate users can't find websites. And phishing. Creating malicious domain names that look real, like G0OGLE.com to trick users. Surveillance ISPs or attackers can monitor your DNS lookups to build a profile of your browsing history. These are usually used to get personal information on all the rest. Now, how does DNS attacks work? Let's visualize a classic DNS hijacking scenario where a hacker inserts a fake page into the phone book. For the normal path, you ask YouTube for the .com and get the real IP. The hijack path, a hacker corrupts the DNS cache. Now, whenever you ask for youtube.com, the corrupted phone book says this, which is the hacker's fake website. You think you're on YouTube, but really, you're on a malicious clone designed to steal your password. In summary, DNS, domain name system, is needed to communicate humans and machines together in order for us to visit our favorite website without a calculator and make browsing easier for us. Thank you for watching. I hope you guys learned something today.